morning students. Today we'll discuss about the shaping and planing operations. Now in this topic, in this lecture we will understand or discuss what is shaping and planing operations, how the machining time is calculated, and you will also be able to solve the numerical problems. Now first we will take the shaping operation. So it is defined as the operation of removing the extra material from the workpiece to produce the flat surfaces. Now here is the basic view of the shaping operation. So this process is done on a shaper machine. You already know the workpiece is held in a vise or directly on a table with the help of clamps. The shaping is done with the help of a single point tool which is held in a tool post. Cutting takes place in a forward stroke and which is known as a cutting stroke, whereas the return stroke is known as the idle stroke because no cutting takes place during this return stroke. So to keep the idle stroke fast as compared to the forward stroke, we use the Whitworth quick return mechanism. The speed of the ram during cutting is maximum at the center and minimum at the beginning and end of the stroke. So next we will understand the formula for calculating the machining time in case of a shaper. So suppose S is the length of the stroke in centimeters and number of cutting strokes per minute, C is the average cutting speed, and L is the length of the job in centimeters. So we will use the basic formula of cutting speed, E is equal to Sn by 100, as we have already used in turning operation. S is equal to pi d n by 100. So pi d is replaced by S. S is the length of the stroke. As in case of a shaper, the effective speed is 3 by 5 of the average cutting speed because we know that the return stroke is fast as compared to the cutting stroke. So we use the formula effective speed E is equal to 3 by 5C, equating both the equations. We get the number of strokes N is equal to 60C by S. Now S is taken as L plus 5 in case of the shaper, where 5 is the overlap of the tool. Now suppose capital F is the feet per stroke in centimeters. So the area swept by the tool per stroke is given by the formula F multiplied by L plus 5 in centimeter scale. So area swept by the tool per minute is, we will multiply by N, F into L plus 5 into N. We will put the value of N as 60C by S and we will simplify the equation. We will get area swept by the tool per minute as 60 cf centimeter square. Now if B is the width of the job in centimeters, Then for calculation purposes, B is taken as B plus 2.5 in case of the shaper. So time required for shaping, this is the basic formula, total area to be swept by area swept per minute. So we'll put the values L, which is the length of the stroke, L plus 5, and B plus 2.5, this is the total area to be swept divided by area swept per minute. So this is the basic formula we are using in case of the shaper for calculating the machining time. Now next we'll take one numerical to understand this shaping operation. I am reading the statement. Calculate the time required for shaping a cast iron rectangular block of size 12 cm multiplied by 4 cm. So L is 12, B is 4 in centimeters. To reduce the thickness from 1.8 cm to 1.6, so depth of cut, that is 0.2 cm. If the cutting speed is 20 meters per minute, C is 20 meters per minute, speed is 0.02 centimeters per stroke, and the cutting time ratio is 3/5. We have to calculate the shaping time. So we will use the effective speed formula, is equal to SL by 100. Also we know effective speed ratio given is 3/5 C. So we put the both the equations. Here is the equation number 1, equation number 2. Equating both the equations, we'll get M as 60 C by S. We already know. We'll put the values of C and S. C is given, that is 20. S is, we have already calculated 12 plus 5, that is 17. So we are able to calculate the number of strokes as 71 strokes per minute. Now the area swept by the tool per minute, we know the formula F into L plus 5 into N. We put the values, F is 0.02, L is 12.5, 12 plus 5, N we have already calculated 71. So this is the area swept by the tool per minute is 24.14 centimeters square per minute. Now lastly we will use the time required formula for shaping, that is total area to be swept by area swept per minute. We put the values L 12 plus 5, B plus 2.5, that is B is given 4 plus 2.5, and divided by area swept per minute, which we have calculated as 24.14. So in this way we will be able to calculate the time required for shaping as 4.58 minutes. This is the required answer. Now next we will take the planing operation. It is also somewhat same regarding the shaping operation. So it is defined as the process of reducing the flat surface with the help of single point tool. The number of tools may be from 1 to 4 depending upon the size of the job or the requirement. This is one of the difference between shaper and planer. Here is the three-dimensional view of the planer machine. Now the common points about this planing operation, this process, this machine is known as the planer machine. Here is the major difference. This, in case of a planer, tool is fixed, whereas job is fixed on the table which reciprocates. So the job is basically reciprocating under the tool. This is the basic difference between shaper and planer. Other parameters almost are same. The work is held rigidly in a vise or directly on a table with the help of clamps, depending upon the size and shape of the job. Planing is done with the help of a single point tool. The tools may be 1 to 4. Cutting takes place in forward stroke, which is known as cutting stroke, whereas the return stroke is idle stroke because no cutting takes place during this stroke. Idle stroke is kept fast as compared to the return stroke because of quick return mechanism, and the speed of the ram during cutting, speed of the ram, you can say the speed of the table in this case is kept fast during return stroke, and the speed of the table during cutting is maximum at the center and minimum at the beginning and end of the strokes. So this is the basic highlights of this planing operation. Now next we discuss about the calculation of machining time in case of a planer. So suppose S is the length of the stroke per in centimeters, M is the number of cutting strokes per minute, C is the average cutting speed, and L is the length of the job in centimeters. Then the effective speed is 3 by 4. Here is the difference between shaper and planer. In that case 3 by 5 in case of a shaper. In case of a planer it is 3 by 4. So the effective speed E is equal to Sn by 100. This is the standard formula, and the ratio is given E is equal to 3 by 4 C. This is equation number 1. This is equation number 2. Including both the equations, we will get N as 75 C by S strokes per minute. Okay. This is in case of a planer. So planer we also take S is equal to L plus 25, and 25 is the forward travel. F is capital F is speed per stroke in centimeters. So the area swept by the tool per stroke is given by length into breadth, that is F into L plus 25 in centimeters square, centimeter or centimeter square. So the area swept by the tool per minute is, we will multiply by the number of strokes per minute, and by substituting the values of N as 75 by 75 C by S, we will be able to calculate this area swept by the tool per minute as 75 CF centimeter square. Now if B is the width of the job in centimeter, then width is taken as B plus 5 over travel for calculation purposes. This is a standard formula. Time required for planing is total area to be swept by area swept per minute. Now we put the values. L time required for planing is L plus 25 multiplied by B plus 5 divided by 75 CF in minutes. So we will next take the numerical based on this planer. I am reading the statement. Calculate the time required for finishing a surface of size 120 multiplied by 30 centimeter. L and B are given, that is 120 and 30 centimeters respectively. On a planing machine, the cutting speed given is 12 minutes per minute and speed is 0.1 centimeter per stroke. So we have to calculate the planing time. So this is the standard formula for planer. L plus 25 multiplied by B plus 5 divided by 75 CF. So you put the values of L as 120, B as 30, C as 12 and S as 0.1. So after making this simple calculation, we will be able to calculate the machining time for planing as 56.40 minutes. This is the required answer. I hope you have understand these two basic operations, shaper and planer, and you will also be able to solve the numerical problems. So do practice for some similar numericals based on these two topics. So students, if you like the video, please share it with your students. with your colleagues, with your friends, and like it. Thank you.